everybody. Gary, thank you very much for the nice presentation, first of all. Well, Gary is in utilities, so that is one of the 5 major industries that we are looking at. So the other ones are oil and gas, pharmaceutical, chemical, and what's the other one?
I should know.
I don't know, the 5th one. Metals and mining, of course. So,
Mining.
So in all those industries, actually, it is about a lot of assets, a lot of information about that. So a lot of drawings that are being managed or need to be managed. And when we look at this entire session, it is about the operate and maintain side of things. But we also consider, of course, engineering and design and build. And from there you have all the modifications taking place into the field and the optimizations you also need to do for the IoT stuff. So that's the point where we are.
Right. Thank you, Ed. Kevin?
I have my own. My name's Kevin Price. I'm with Infor. The things that we manage are things that are assets. If you got an asset, we can help you. When they're more complex, it's the better, because we have a very open system and framework. As David was mentioning, the Internet of Things is really playing into very well, because the application by design is very open, very configurable to work with a lot of different types of environments and industries, and it's also designed to hold large amounts of data. But at the same time, do it in a way in which customers can upgrade from one place to the other. He upgraded his environment 24 hours after we released it. So when you have around 2 million assets with a 25-year history, you need to be able to have an architecture to do that. So the way we build is to remain open, to be able to pull in data as necessary to make good decisions and better decisions, but also be able to scale at will by design. Thanks.
Hi, I'm Dave Gassier. I'm the offering manager for the IBM Maximo product, and similar to the Infor product, very similar. We're used by customers in many different industries, everything from the government, different governments. The national parks use it as well. Oil and gas, utilities, and manufacturing are very big. Our perspective right now is, we're in a good position where we're also building out an IoT platform. And we're really looking at how we can pull together our Maximo Asset Management product, leveraging the IBM, or now Watson IoT platform, to be able to really enable our customers to make the connection from their smart devices and pull that information directly into Maximo and leverage it for big data, improvements in the way they maintain their facilities and assets. So that's our big push right now.
Thank you. Thank you very much. Any questions from the audience? We got one.
Hi, John Campbell from Tech. I have a question for Gary and Edwin. You talked about going out and training the people, and you have your detractors and your champions there. And the goal was, of course, to get people to start putting the assets into the system and using it. What really attracted the champions? What were the things that got them excited about using the system, the use cases that they saw as providing benefits?
So I think for us, the primary issue was with the implementation of this software, we were also implementing a completely digital signature process. And some of our younger engineers who were not so entrenched were very eager to adopt that, and they became very vocal champions of that. Some of our older engineers who'd been around a long time really fought and pushed against that electronic signature. They argued that it violated their PE organization in the States, policies and all sorts of things. But in the end, in reclamation at least, now we have policies in place that the only way an engineering drawing is signed is through the implementation of our Meridian software. And so, again, those early adopters, those young engineers, were very helpful in promoting that idea throughout the organization.
Another question? Mary?
Thank you.
Okay.
start. So our installation is completely safe. So we might not generate black holes where we will disappear, so that's quite clear. But the thing is, things become radioactive in our plant. And there we have strict rules about how we have to trace radioactive material, how to make sure that people are not exposed to more higher doses than required, and so on, absolute minimum. So there we use our tools to trace this as well. And what we have seen is that a key thing there is to have simple interfaces to make it easy to understand this kind of basic information, but it can be very important for safety. So for example, when it comes to radioactive material, we use self-service kiosks to actually check out and check in equipment that might be radioactive, to trace where they are at any given moment. But that can be used without any training whatsoever. So our tendency there is that to make things as simple as possible, especially when linked to important things like safety.
Good.
I'd like to add something to that. So in our philosophy, the safety is driven by accurate data, actually. So not only data, but also information provided to the workforce. So when they go out in the field for a maintenance work order, then they need to have that accurate information. And one of the most crucial parts is the modifications taking place, the constant change, actually, that needs to be fed into operate and maintain. So the people who are on site need to rely on that data. We can't avoid if they don't look, but at least our systems give you the possibility to have the accurate information. So with the integration between Maximo and Meridian, it is, I have a work order for the piece of equipment, and with a click on a button, you get all the information available to you, and it needs to be accurate. And the process behind that, of course, needs to be managed in our system to make that sure.
I'll add just a little bit. We do a good bit also along some of those lines, but we also, for the environmental piece, we found in our facilities Maximo database that we put in our the spill dikes around tanks, our wastewater runoff systems, and the holding ponds, those kind of things are in there, and that's greatly eased the auditing process and dealing with EPA and things like that. So from that point of view, it is greatly reduced the time and effort spent there, and made us much more compliant with those regulations.
Good. Good.
Well, that was one of the questions I was going to ask. That was good. My second one is have you guys started thinking about using augmented reality as well, besides just the mobile tablets, but glasses and different things when you're out there to gather that data and actually do it in real time right there and talk to an operator or fix something?
Start? Okay, so yes, we have. So in fact, we were quite early testers of the Google Glass things to see how we could use this to actually prepare and provide information to the people intervening in the accelerator. Because again, it's a radioactive environment. You have to go in and get out as soon as you can. And you have to have the right information. So if you're in front of a piece of equipment, it would make sense to have all the information there. This is necessary for you at that given moment. Somewhere very simple, for example, through the Google Glass in this case. So we've been trying this, but it's been more like providing information to the technician in the field and not so much collecting information so far, but that's also a very interesting use case. And what we're looking more into as well is to see how we can use our 3D CAD models that we have also linked to our assets in this case. We can see how we can show how it should be, so we can prepare and train the technicians with the CAD models before they actually go in. So we do simulations, we train certain interventions, so just to reduce the time in the tunnel by efficiency reasons, but also by radiation issues.
I'd like to add something to that. So we did an experiment with CGI actually for Google Glass, and we're in the field of drawing management, very, very basically set. And when you look at USBR, they have a lot of drawings still in paper form archive. So that needs to be digitalized. And if you send somebody into the field to do the work order, so to say, and he needs to get instructions. Then many of those instructions are in very lengthy PDFs as standard operating procedures, or in large drawings, PNIDs or whatever. And it needs to be cut into smaller pieces because there's only a very limited amount of space in your glass to get that information and act upon it. So it is quite an effort that an organization has to go through in getting all this more or less legacy data into the future.
To touch on that a little bit more, the Infor Science Labs group and the user design team that we have are taking the concepts of the augmented reality combined with the dilemmas of the asset, the data that comes in, and bringing it into a one user interface to make a decision. It's more of a decision as a service. So as we saw earlier in the opening sessions that we have, a lot of those data elements are coming together in the cloud, then being communicated out into various forms, whether through Oculus, different types of things around Google Glass, even some elements that are easier to use, even in tablets, to make better decisions on how to handle that asset in a safe way with all the safety considerations that are brought in, all the regulations that are under consideration, the history of the asset, the performance of it in real-time monitoring, these types of things. But it's bringing to bear in that one interface. We see it coming, and we're doing some efforts to be able to bring it to reality.
So I think what we need is a Watson system within reclamation to analyze all the data and then provide the key elements back to the technicians in the field. The problem for us is that 80% of our stuff is still in paper form, and we have to get that into a digital form and then digest that. And when you think about digesting 10 million engineering drawings, plus all of the SOPs and the other information that would go along with that in terms of a maintenance arrangement, I think it is, at least right now, it's premature for us to start thinking about how we're going to accomplish that. We know that in the future, that's going to be something we're going to want to tackle. But I think, honestly, we're going to need some sort of analytic process to help go through all of that information and provide the key pieces to the technician in the field who's actually doing the work.
Yeah, let me just weigh in on this just a little bit. The 3D goggles and glasses and that kind of stuff seem to, they're cool. They get a lot of attention and stuff like that. But I've seen demos where a technology that's a lot more pervasive, like tablets and cell phones, are used. And it's my assessment belief that this will be at least initially, the primary adopter in terms of quantity of augmented reality, where you can point this at an object. Maybe there's some kind of QR code on it or something like that it identifies and then starts putting information on the screen, layered on top of the screen, so you have more information about that particular asset. I think this is where augmented reality will have fairly good and probably rapid adoption, because we all have the means to display it in our pockets. And there will be need for 3D glasses in some other areas. I've seen some very neat demos where they're used to help a maintenance person disassemble. So you got both hands free in this case. So the maintenance person has instructions layered on top of what they're actually looking at and can assemble or disassemble something, do a maintenance operation. That requires a bit more development, and for the particular operation, it isn't out-of-the-box type stuff, but that is definitely a good application for the Google, not Google necessarily. There's plenty of other people who have products on the market now that are very functional, those glasses will be adopted. Any other questions? Oh, good.
All right, so you all touched on having to manage lots of assets for some period of time, in various cases, a very long time. Can you touch on any strategy you have for long-term archival retrieval and how that includes the systems you're currently using?
So I think For us, we're going to continue to work with the Blucello Meridian Enterprise solution. We believe it has the capability to meet those long-term storage needs. And it's interesting, the archival for us is probably not going to be, most of our drawings are going to stay pretty active even when we get all 10 million of them in there, because it's sometimes very important for an engineer to be able to go back and see what was done in previous versions of that document. And we want to make sure that those things are available. So in terms of archival, we're probably not going to be doing a lot of that, but we're going to be housing all of those drawings and making them available on an as-needed basis.
Yeah, so in our case, we have, it's true we have plenty of assets. We also have lots of documentation attached, so we have a few million drawings in total at CERN. And of course, we're going towards these standards. We don't just go with the flow. So we have a PDF/A as our standard for long time archiving. We don't want to do any research in this. We just go with where the market is going and go with the flow. So it's following the ISO standards. They believe that if all the big libraries around the world go in that direction, well, we go the same direction. So no need to improvise there.